So in today's session, we are going to look at reflection. Reflection is a kind of, geometrical transformation. Now, of course, in general, geometrical transformation is an operation that changes the position and appearance of a geometrical figure. Now, if this what right we want here, for example, this could be a geometrical figure. Now, this geometrical figure can either be enlarged, meaning that we make it bigger than this. It can either be moved from one place to another. In the term we use for that is translated, meaning you move its position and from one place to another, or it can be reflected. That means that a mirror it's reflected through a mirror, or it can also be rotated. So we are going to explore all these kinds. These are the kinds we call geometrical transformations. Just like the definition here says that a geometrical transformation is an operation. These are the operations that are being talked about when we say that a geometrical is an operation. So it's an operation that changes the position and appearance of a geometrical figure. So a geometrical figure can either be enlarged or translated or reflected or rotated. So in today's specific session, we are going to look at reflection and we are going to look into it in detail. Then in upcoming sessions, we shall go on looking at the other kinds of transformations, that is, enlargement, translation, and rotation. So let's get started with this. I'll be explaining these notes, and while I'm doing it, I'll be making a few illustrations on the side. So that is what we mean by transformations. So let's talk about line symmetry. Now, a line symmetry or a line of symmetry is simply a line that divides an object into two equal parts. And it divides it into two equal parts in such a way that if you fold those two parts, they will fit into each other. Let's say this is a book. If you look at the book, this is a book and this is the middle of the book right there. And this is, that's a book. It means that if I fold this book and it becomes like that, if I fold it, I have folded it along its middle point. And I folded it in such a way that this side of the book will fit exactly on the other side of the book. So when that kind of thing happens, that line along which the folding took place, that line is what we are calling the line of symmetry. So that's what we are talking about here, that a figure has a line of symmetry. If both sides of the line are the same size and shape, then any two opposite points are the same distance from the fold line. For example, if this is a book, let me draw it here again. If this is the book, and this is our line of symmetry, and this is point A, and that is point B, what they mean is that any two points are the same distance from the fold line. So we are having a point here, point A, point B, and this is the fold line right there. So the distance here is the same as the distance there. The distance of those 2 points are the same from this fold point, and also the line joining the 2 points is perpendicular to the fold. As you can see here, this line is meeting the fold line at 90 degrees. So that's what they mean. If you look at this diagram here, we are having a line of symmetry. It means that this is the line along which you're going to fold that polygon. You'll fold it in such a way that now each side will fit into each other and it will all become like that. That is after folding. So you folded it along this line, and that is what we call the line of symmetry. So again here they say that two shapes are congruent if they have the same size and shape. So take note, we are going to be using this terminology a lot, congruent or congruent angles. I mean congruent shapes. So shapes are said to be congruent when they are the same size and the same shape. So of course, if they are having the same size and the same shape in such a way that they fit directly into each other, for example, this and that are directly congruent actually. When they fit into each other, they are called directly congruent. So if we slide and fit one into the other without turning over one of them, the figures are directly congruent. And if that condition is not being satisfied, it means they are oppositely congruent. Okay, so let's talk about the real deal now. Reflection in a plane mirror. Now we've all been before a mirror. When you stand before a mirror, you get a reflection of your face or your image in the mirror. So if you have done some physics, which is definitely the case, it means that if this is my mirror right here, and my mirror looks like that, right there. So meaning that if I am here standing this side of the mirror, I will get my reflection like that. So now one thing you should know about reflection is that my distance here from where I am to the mirror, that distance is the same as the distance from the mirror to where my image is. Those are the laws. So if I'm standing here, this is what we call the object. And what I see in the mirror is what we call the image. So let's first go through the notes here. A reflection is a transformation such that the two corresponding points on an object and that image are both the same distance from a fixed line. And that fixed line is what we are calling the mirror right there. So it's same distance from the fixed line, and any line joining these 2 points is perpendicular to the fixed line. So if we have any line that is joining these 2 points that are being reflected, that line is perpendicular to the fixed line or perpendicular to the mirror. So it goes on to say that a plane mirror is a normal flat mirror that gives an accurate reflection. Okay, the figure we are reflecting is called the object. I've already talked about that. And the reflection is called the image. The line along which the edge of the mirror rests is called the mirror line. We've talked about that. Under reflection, objects and images are symmetric. The mirror line is this line of symmetry. In other words, the mirror line divides the object into two. So if we have a ball here, and this is the mirror line, like that. So it's reflected here, that's the image. So that mirror acts like a line of symmetry between the two. An object point and its image are the same distance from the mirror line. I have talked about the issue of distance. You can even find this in physics as under the laws of reflection of light. Then reflection alters direction except for parallel lines to the mirror line. The objects are literally inverted, meaning that, for example, if you look at yourself in a mirror, your face, while you're standing, you see an image of you looking at you. And so if you have your right hand, having your watch on your right hand, you will find that in a mirror, it will look like it's your left hand that is having the watch. That is what we mean by lateral inversion. It's the same with words. If you look at, you put like words before a mirror, like you've written like gain, like this, and this is the mirror. So in the mirror, it will look like this gain. The word has been inverted. That's what they mean by lateral inversion, but let's not dwell so much on this theory. This theory is more relevant with physics. Let's move straight to the mathematics of it. So the mathematics of it here, what we are concerned with is, this is an object right here with A, B, C, and this is the mirror M. So if we are to reflect this through this mirror, we are calling M, and we put it here, we simply have to get a ruler, measure the distance from here to there. Make sure the distance from here to there is the same as the distance from there to there, using a compass. It is the same thing here. The distance from here to there should be the distance from there up to somewhere there. Okay, I'm just estimating the distance of point B to there should be the distance from there up to somewhere there. So this is B prime, this is C prime, this is A prime. And so when I combine all those 3 points, this to that, to that, to that, we combine that and we have an image. And this is the object. It's just that straightforward. Let's try and demonstrate how reflection works by reflecting a few coordinates here. We have an example here. Let's try and demonstrate how reflection works by trying to, reflect some coordinates here. So we're going to draw a grid here. They're telling us that find the image of the point P, which is negative 3,4, under the reflection y is equal to 1. So let me draw this grid here. We have something like that. Okay, so we have an image. Let's say this is negative 1. So we have a point here, negative 3,4. This is negative 3,4. This is 1, 2, 3, and 4. So negative 3,4 is right there. So I'll mark it with a dot. That's point negative 3,4. And we're being told that point negative 3,4 should be reflected under line y is equal to 1. So meaning that line y is equal to 1 is our mirror. So we're going to draw our mirror, and it's the straight line whose equation is line y is equal to 1. So line y is equal to 1 is a line where all values of y are 1. And so that line is right here. This is line y is equal to 1. It means that all values of y along this line are 1. For example, this is point 4,1, this is point 3,1, and so on. All the values of y are 1 along that line. So that's the line y is equal to 1. So we are reflecting this point along that line. So meaning that this is our line. So what is going to happen is, we remember that we're supposed to count how many boxes are here from this is the object. Okay. So how many boxes do we have to the mirror? That is 1, 2, 3. So meaning that there are actually 3, because here there are 3 units, because here we've represented it in such a way that 2 boxes make 1 unit. So there are 3 units. So meaning that if we have 3 units to the mirror, it means I am going to count another 3 to locate where the image is. So it's going to be 1, 2, 3. So it means that my image is going to be at that spot. So if that's the object, that's the image. And so my image is located at, if I may label this is negative 1, that is negative 2, this is negative 3, like that. So meaning that my image is located at this point, and that point is negative 3, comma negative 2. So that's it. Find the image of the point negative 3,4 under the reflection y is equal to 1. So that's the image. The answer is negative 3,2. Let's try and do part B. Part B says that after the reflection in the line y is equal to 1, the image of point 2,5, the image of a point is 2,5. That's what they mean, that after reflection in the line y is equal to 1, which we've already drawn here, the image of a point is 2,5. So where is 2,5? 2,5 is right here. So this is 2,5. Let me try and draw this better. All right. So we are being told that after reflection in the line y is equal to 1, which is already this line, the image of point 2,5, the image of a point is 2,5. So the image of a point is 2,5. Where is 2,5? This is 2,5. So this is 2,5. It's right there. This is point 2,5. And now we're being told that its image, where is this point? Because its image is 2,5. So if its image is this one, and it's being reflected in this mirror, so it means that the object is down here. So how do we locate it? We are going to use the same. We're going to look at the distance. The distance here from where the object is. The distance from here, this is 1 unit, 2 units, 3 units. So there are 4 units to reach the mirror. So we are going to count another 4 units away from the mirror. So that's going to be 1, 2, 3, 4. So it means that the object is right there. And what's that point called? That is actually 2, negative 3. And so that answers part B. Of course, when you're locating those, you don't need to put this. I'm just putting these ones there for working, just to show you how I'm arriving at the answer. But it's just, just that. So basically, when we are trying to um, reflect points, that is basically how we go about it. It's that simple. And so even as we are doing complicated numbers, when we are coming to reflection and we reflect points, even when it is a polygon and we say this is a polygon and it should be reflected, when we are reflecting a polygon, we are actually reflecting the points in that polygon, like we shall be seeing in our later sessions.